Welcome everyone. In this video lecture, we will write the state space representation for a RLC circuit. In last video, I have made the RC circuit and their state space serialization. So I will share the link for those who want to go for the RC circuit. So today we will write the state space representation for the RLC circuit. So the very first thing, the very basic thing that we can say, so a state equation can be written as x dot equals to any equation can be written as ax plus bu, okay, and y equals to cx plus du, okay. So first of all, in this case, so this one is our, we can say the state equation. I will show you how to solve this kind of circuitry very easy, in easy way, okay. And this one is our output equation, you can say state equation, output equation, okay. So first of all, we have to identify the order of the system. So here the order of the system is 2, because 2 energy storage element, 2 energy storage element, we can say, like one L is there and C. So this is the second order system, order 2, or we can say the second order system. Now, so in last video, if there is some inductor, we have to take IL as a state variable, and if some capacitor kind of thing, we have to take sorry VC as a state variable, okay. Then we have to think about this circuit, okay. So I have already told that the IL be the state variable, and this variable, that is our VC, two state variable, second order system. Okay, so we are saying IL current is flowing, so the same current will flow through this resistor IL. So now, how to write the equation? So say this point is A. Okay. So first of all, or before that, if you write a equation in this loop, say loop one. Okay. So in this one, how to write the equation in loop one? We can write as plus Vs minus IL R1 minus, okay. Now we are writing in terms of voltage. So what should be the voltage across this side? Plus of minus VL. So that plus minus VL, if this one is inductor and this one is our some voltage VL, so VL can be written as L DIL by dt. Okay, so simply what we can write, minus L DIL by dt. Okay, because in this case the voltage drop is our say VR1, and in this case plus minus VL. So then VR1 minus IL into R1 minus LDIL by dt, and minus VC equals to 0. Okay, so again we have to rearrange this equation. So this one is two energy storage element L and C. So two differential equation will come. Okay, so first equation is like this. So we can arrange like L DIL by dt. We put in the right hand side. Okay, then we can write R1 IL. Okay, R1 IL clear with minus sign. Okay, minus VC minus VC. Okay, plus Vs. Okay, we are just putting this one in the right hand side, and then so we can write L DIL by dt minus R1 IL minus VC plus Vs. Okay, or one more line we can write DIL by dt equals to minus R1 IL IL minus VC by L plus Vs. Okay, Vs by L, because we have to divide. So this one is one equation. Say equation number one. Okay. Now what we can say? One equation we have already written. Okay. Now one more equation we have to write. So one more thing that we can say. Say this current is a IC current, and this current I am saying IR2. Okay, that is flowing through this, and this is point A. So now we have to write KCL at point A. Okay, I am highlighting this one. KCL at point A. So what we can write? The IL current, total incoming current equals to outgoing. So IL equals to IC plus IR2. So IL is a state variable, so no need to disturb. You have to write as it is IL. So I am writing IL. And IC2, the current across the capacitor. So this voltage is VC. So what we have to write? C dVc by dt. Okay, if some capacitor is there, then the IC current will be C dVc by dt. Okay, so we can write like this. Okay, or you can say Q equals to CB, Q equals to IT, so IT equals to CB. So we can remember like that also, C dV by dt. Okay, this is just some basic. So IL C dVc by dt plus IR2. IR2 is nothing but simply VC, because V0 or VC are same, plus IR2. So IR2 VC by R2 plus VC by R2 we can write, or V0 by R2, or this voltage V0 equals to, here V0 equals to VC. So I am writing VC by R2, because first we are writing a state equation. So we are introducing the state variable. Our state variable is IL. In this case, our state variable will be simply IL and VC. Okay, so this one is one more equation. So write the, in terms of C dVc by dt equals to minus Vc by R2 plus IL. We can say this one is one more equation, or we have to write this one, or I am writing, yeah, dVc by dt equals to minus Vc by R2C plus IL by what, C. Okay, plus 0 times of no Vs term, so we can write like simply. Okay, so here I am writing the second equation, a state equation, dVc by dt equals to minus, okay, minus Vc by R2C plus IL by C. Okay, say this one is our equation number 2. Now we have to write the state equation. Okay, so first state equation. So what we can write in the matrix form? IL dot, okay, and VC dot. Okay, IL dot DIL by dt, VC dot, and then we have some A matrix A times of X. So that X will be what? IL, and here Vs. Just like X dot equals to AX plus BU. Okay, so this one is our X dot, IL dash VC dash. Now we have to write the matrix. So what we can write? Minus R1 by L minus 1 by L. Okay, this is the minus 1 by L. And in this case, what we can write first? IL by C in the first case. So this one 1 by C minus 1 by R to C. Okay, means here you can interchange this side you can write, and you have to write like this. Okay, plus B into U. So U is what? U is our input source, input variable Vs, and now the parameter B parameter. Okay, so plus B parameter. So Vs. So here Vs. So what we can write 1 by L, 1 by L and 0, because this term we can say 0 times of Vs. So 1 by L Vs. So this one is the matrix. IL dash VC dash. Okay. So this one I'm just this one is our matrix. Okay. I'm just putting in, so this one is the matrix. Okay. This one is the form x dot, but two differential equation we have to write IL dash VC dash. Then now we have to write for the output variable, output V naught. So here again what we can say, V naught is what? V naught is our VC, output equation. Y is our V naught. So what we can write? Okay, we can write V naught equals to VC. So one more expression, y equals to Cx plus du. Okay, so V naught equals to VC. Okay, so this one is the only solution for this differential, means this RLC circuit. Okay, so what we can write, this one V naught equals to Cx. So x will be what? The state variable. You have to write IL VC plus U. U is what? Vs. Okay, so this should be our 0. Okay, no, in output term no supply is there, so Vs 0, so I am just putting a 0. And for this one, what we can write? 0 and 1, because 0 IL and VC. So this one is the output one, or module 0 1. You have to write this one IL VC plus 0 times of VC Vs, sorry, source. Okay, so this one is the another equation for the state output equation. Okay, so this one is the state equation. Okay, so this is all about this simple realization for this state space analysis. So you can directly write the whole equation very simply, but just first apply KVL in this loop and try to write some current equation KCL, and this one is our KVL. Okay, so KVL in this side, KVL in loop 1, you can say, writing here KVL in loop 1. If you apply KVL in loop 1, we can write this equation and KCL at this point. So, but every time remember, for the inductor, the IL with the state variable. For capacitor, you try to write VC, either incorporate this thing and write the two differential equation. So two differential equation will automatically come. One differential equation, second one, then try to arrange it. Okay, these two equation. Okay, then IL dash VC dash, just use this one. X dot equals to AX plus VU. X is a state variable, A state matrix, V is the input matrix. Okay, U is the input. Okay, so like that you can write the state equation and output is simple. V naught equals to Vc. Like that we can write the output equation. This is all about the simple realization for the state space representation. So thank you for watching this video. Thank you.